left, it's time to show you guys the first explosion. Oh my gosh, look at that. There we go, guys. That is the Western Veil Nebula. Have you ever heard of the term supernova? Now, if you're curious to wonder what this term means, it is a star that exploded in space. Now, the term supernova really goes around in a lot of different areas and can describe a lot of different things, especially in life or in just everyday language. Some people may use this term, but its actual term is a star that exploded in space. Now, believe it or not, stars have lives just like we do, as well as everything in space. I mean, we're made of space dust, guys. And just like stars, they are born, they age in life, and then they eventually die. But when they die, they leave something crazy in space. They leave explosions in time. They also leave behind vibrant colors, but these colors, while they're nice to photograph, they also have a very crazy past. And if you were in one of these explosions, again, while they're colorful, they are extremely dangerous. Tonight, I will be photographing a supernova remnant from my backyard telescope, and we'll be showing it to you guys at the end of this video. This is Tanner from TH Astro, and welcome to the YouTube channel. Now, recently in May, a supernova was discovered in one of the nearest galaxies to us, Messier 101, the Pinwheel Galaxy. Now, this supernova was called SN 2023 IXF. Now, supernovas are not just located in nebulae, as you can probably associate these supernova as a lot of these colors that we see in nebulae. But in reality, they can exist in anywhere, like galaxies, and even our sun can turn into a supernova. Now, while our sun is nowhere near this age, it still may very happen in 4 billion years or so. We just don't know. Like I said before, supernova go through an age just like us humans do, and animals, plants, everything associated with life. Supernova first begin as young, hot blue stars and appear rather small at first, but over time, their colors shift to warmer colors, which signify their age in space. Now, their age is much greater than ours, and they could last between millions to billions of years. But as they age, they grow larger and colder. And even though their color, as they go older, appears warmer, they are getting colder. And when they get colder, they expand, and eventually their matter begins to decompose, and they leave behind a giant explosion. These traces that these stars leave behind can very well even reach our atmosphere and our solar system. Now, while this hasn't happened yet, supernova are actually very, very dangerous and can even shoot through our atmospheres and cause harm to even us. Now, but luckily, that's never happened yet. Now, recently in the Orion constellation, we discovered that the star Betelgeuse, which is a bright orange star that makes up part of the Orion constellation, is actually starting to die, and it is dimming and brightening every several months. Now, while this star hasn't exploded yet, this gives us signals that the star can even explode at any time, and luckily for us, NASA says that there won't be any effects on us, but it will mean that this star will leave a bright patch of the sky, theoretically. Now, I just want you to picture how many stars are actually in the universe itself. While there's billions of trillions in galaxies, just think about all of those stars all together. Now, when you think of trillions upon trillions of these stars, you may assume that just hundreds of thousands of stars just explode even at any second in comparison to how big our universe is. And that is very well true. Stars explode all the time, just like, sadly, how people or animals pass away all the time. Our life and stars' lives are just the same. Now, tonight I will be photographing a very famous supernova remnant in our own Milky Way galaxy called the Western Veil Nebula, or Witch's Broom Nebula. Now, this nebula is located in our Milky Way galaxy itself and isn't even that far away from us. And of course, this is from a star that exploded thousands of years ago. Now, it left a huge ejection of stardust, which is part of a larger complex called the Veil Nebula Complex. Now, this is located right below the constellation of Cygnus the Swan, and it is a huge target that I just cannot take a photo of all in one go because of the sensor size and my telescope setup. It is just too big, so I will be focusing on one part of the nebula itself, called the Western Veil Nebula. Now, this nebula left behind colorful traces of O3 and hydrogen alpha dust, which are the blue and red colors that I was explaining earlier in my previous video, so make sure you check that one out. Besides the Veil Nebula complex, one of the most famous supernova remnants is actually Messier 1, the Crab Nebula. Now, even though this is a very small and somewhat dim target compared to the Veil Nebula, it was actually quite the topic for discussion thousands of years ago in ancient civilizations. When this supernova exploded back thousands of years ago, who knows what these people would have saw in the night sky. It could have been colorful colors or even a second sun compared to them. Maybe they didn't even have a night sky in the first place, and this supernova was just so bright that it just completely shrouded all the stars. Other supernova remnants can include also planetary nebulae, which to astronomers hundreds of years ago thought were planets, but they were actually nebula or supernova that exploded, and actually they looked like planets themselves. Now, a famous supernova remnant or planetary nebulae is also Messier 27, the Dumbbell Nebula, which is a very bright planetary nebula with O3 and HA emissions that is a popular target for astrophotographers, including myself. So now that we got the history and all that taken care of, let's start setting up our setup, because I have an image and I have been really depressed lately because of all this darn smoke. But luckily tonight is looking clear and the smoke and haze have finally gone away, at least for a little bit, and we will finally be able to image under some pristine clear skies. So I feel like I didn't really explain much on narrowband filters and why they are such a crucial part in astrophotography in blocking out stray light and moonlight. Well, today I brought my filter with me here to show you guys. This is the Optolong L-Enhance. Now, the Optolong L-Enhance is an extremely powerful filter. Now, this filter, like I said earlier in the past video, will isolate the HA and O3 band passes in the light spectrum. Now, you might notice that when there's a full moon, or if you're just in a light polluted area, you might not be seeing a lot of stars in the night sky, and your thing just appears brighter. Well, that can be blamed on those lights in the moon. Now, when you're taking photos of space, your camera will pick up all of that stray light in moonlight. But if you have a filter, these filters will block out a lot of that light that we don't want in our pictures. Now, when you're taking a photo of something without a filter in a light polluted area, you might notice that you don't see as much of that star cluster or galaxy or nebula as you might want, because the stray light in the moonlight will block out that nebula. It will wash out the stars along with that nebula. So that's why we have these filters to isolate those nebula bandwidths of light by themselves and completely get rid of all of the moonlight and the stray light that we don't want to see. By the way, these filters get expensive. Well, it is starting to get dark, and if you're an astrophotographer, you might know this term. It's gonna be one of those nights, and I really think, I really think it's gonna be one of those nights. I'm excited to do this one. I haven't done this one in a year, and I can't wait to see with what my new camera and filter can do on this target. Okay guys, so the sun is set and everything is up and ready to go. Just waiting for it to get a little bit darker now. It is currently 9:31 p.m. right now, and we just aligned with the North Celestial Pole, so our mountain is going to be able to track the sky accurately now. Now the only thing I have to do is wait for my camera to cool down, and then we are ready to go, guys. I figured that one thing that I would talk about is how do I align my telescope with the North Celestial Pole? Well, it's not as easy as you would think. Even though Polaris is one of the only stars in the night sky that doesn't move, that still doesn't mean, quite frankly, that it doesn't move. It still moves, but only very slightly, to the point where we wouldn't even notice. So there's an app that you can download on your phone to help you align your telescope mount to Polaris, called Polar Finder. You can find it on the App Store on any phone, I'm pretty sure. And what this will do is it will tell you, according to your telescope mount's polar scope reticle, where exactly Polaris should be in the reticle. Now, it appears as a big circle, and Polaris will rotate around that circle if you align your telescope to it correctly. Now guys, I was just doing some framing adjustments to my setup, and I want to show you guys something that's really cool. You can already see our target in this 5-second exposure. There it is, the Western Veil Nebula, a supernova remnant, just in that 5-second exposure, and normally I take 5-minute exposures. So I thought before I get everything going and show you guys the first exposure, I just wanted you guys to see how cool that looks so far. Alright you guys, it is almost time to reveal the first 5-minute exposure that's coming in. And by the way, comment if you want me to show the first exposure of every target for every video upcoming. I think it's going to be a pretty good idea. Now, before I let you guys go and reveal the final image at the end of this video, I just want to say thank you for watching, and I am really glad that I got my first video out of the way, in all honesty, because it was pretty nerve-wracking for the first time for me talking in front of a camera, but now I feel way more comfortable. Oh, that was just a shooting star, I think, or maybe that was a firefly. I'm an idiot. But anyway, we have 5 seconds left. It's time to show you guys the first exposure. Oh my gosh, look at that. There we go, guys. That is the Western Veil Nebula. And if you look, you can see that is the target that we were imaging, and there is a whole bunch of other nebulosity around it. This is just awesome to see. And we have our setup, of course. This is just truly incredible. This is the first time I'm seeing it as well. I can't believe this, man. I can't believe what I'm seeing. which signify their age in space.